Okay, now there's a couple formulas that we're going to use in this wave section. We're first going to do the wave speed formula. And your wave speed, this is v, and this really stands for velocity. But the velocity and speed formula are exactly the same. And we'll talk later about what is the difference between the two. But it's basically your displacement or your distance over your time interval. Okay, and this d, delta d or delta t, if you guys have ever seen this in math, is just your final minus your initial. We have a couple other formulas. We've got your period, again, is the time it takes to complete one cycle. And then your frequency is the number of oscillations the wave makes per second. If you have like a storm coming, the frequency of waves will be much higher than if you don't have a storm, because those waves are going to come in and come in and come in and come in, where if you didn't have a storm, they would just kind of like roll in, roll out. And your frequency is always measured in seconds to the -1. Now, if you remember from math, seconds to the -1 is equal to 1 over s, which is also equal to hertz. Okay, and so you guys may know of hertz. You may hear different things with sound with hertz, and that's really just measuring the frequency. And your frequency formula is F equals 1 over T. This sometimes doesn't look like a 1, so I'll draw it to look like a 1. And then you can also put this formula in the triangle, which is really, really handy. And your period, because it's a time, is measured in seconds. Here's your wavelength formula. Wavelength is this weird little letter. This letter is lambda. It's a Greek letter. You'll see a lot of Greek letters in physics this year, don't worry. And this is your speed, and this is your frequency. And you can also put this in the triangle. So we have 3 formulas that I've given you. We have speed equals distance divided by time. You have wavelength equals v over f. And then you also have f equals 1 over t. And so these will be most of the formulas that you'll use this unit or when you talk about waves. So let's try and solve a problem. We have a sound wave, and the frequency of this sound wave is 192 hertz. And it travels the length of a football field, which is 91.4 meters, in 0.271 seconds. What is the speed of the wave? So let's label these things. This is a frequency, right? This is a distance. This is a time. And this is a velocity or a speed. Okay? And so we know we have a frequency of 192. I always write what I know, even though I've underlined them. I still write them over here because sometimes the formula or the problem gives you all these things you don't need, and they have all these extra words and things. And so I just like to go ahead and write it to the side so I don't have to worry about looking at those questions anymore. Okay, so I have my frequency, my distance, my time. You can see I've left a space for velocity, and I've got units. So I'll take points off your quiz or your test or whatever, your lab, if you don't put units. So if you go ahead and you leave a space for the answer and you already put the units in, then when you put your numbers in, you can't forget the units because you've already written them down. And so it's pretty handy. So the first thing it asks is, what is the speed of the wave? And our wave speed equation is v equals d over t. So we have a d. It is 91.4 meters. We were also given a t, which is 0.271 seconds. And so we can do 91.4 meters divided by 0.271 seconds, and we'll get 337 0.27 meters per second. And this is actually a reasonable answer. The speed of sound in air is usually at like 20 degrees. The speed is 343 or something like that. And so we can see that this is a reasonable answer. And you'll see that when you get to sound. And again, we have our meters over our seconds, so we're going to have the right units. So our answer should be correct. Now part B says, what is the wavelength? So again, we've got this frequency of 192. We have a distance of 91.4 meters, and these are all the numbers from before. And now we have this extra number that we got in part 1. So I'm going to go ahead and write that because can never have too many numbers. And then we want to know the wavelength, and our wavelength is at lambda, and it is in meters. Our wavelength formula is V over F. So we're going to use this one right here, this frequency, and we're going to use the velocity we got from part A. So you can see the units, because I think it's kind of handy, especially for frequency. So I have meters per second, and then my frequency is 192. And if you remember, hertz is actually seconds to the -1, so you put your seconds on the other side. And so you cross that out, and you cross that out, and all you have left are units of meters, which is really great because wavelength should be in meters. So you know as long as you put it in the calculator, you'll correctly, you'll get the right answer. And I got 1.76 meters. Now, the third part of this formula. Okay, I'm going to do it again. I'm going to go ahead and write down all that we know again. We have 192 hertz. We have a distance of 91.4 meters. We have a time of 0.271. We have a velocity of 331.27. We have a wavelength of 1.76. You can see we're starting to get a lot of information about this wave. And then the last thing that we want is the period. And remember, a period is a big T, and its units are time. And the formula, the only formula that we have that has period in it, is this frequency formula. Right? Because this is a big T. This is a little t. This is not the right formula. This is the right formula because that has a big T. So you're actually, you can put this in the triangle if you don't like doing algebra. So we have 1 over t on this side. So I'm going to put the 1 on the top and the t on the bottom. And then the f is by himself, and I'm going to put him over here. So we have f equals 1 over t. Now, I'm not going to give you the triangle on the test, but if you know how to make the triangle, you're more than welcome to use it on the test. So make sure you know how to make them if you start relying on them. We want the period, so I kind of like to cross out the one that I want, so I know how I want to draw my formula. And then I'm going to have 1 over 192. And remember, because this is hertz, or seconds to the -1, the s goes on the top. And the units for period is s, or seconds. So we know that that's okay. Now, there's a couple answers that you guys might get for this. My calculator went ahead and showed me this. But some of you may get something like this in your calculator. Both of these are fine. They're just a different way to write the same number. This is scientific notation, which we learned in Unit 1. All three of these are a fine way to write your answer. I don't care which way you write it. Either way, well, either is for 2, but any one of these is fine. I don't mind. I don't care. Now part D says, if we change the frequency to 442 hertz, so we have a new frequency, what is the new wavelength in periods? So we're going to have to find the wavelength again. We have the same distance, the same time. I'm not sure if we'll have the same velocity or not, so I'm just going to put it like this, and then we'll check it out and see what happens. And we're going to have a new wavelength, some meters, and a new period, which is in seconds. Now, our velocity equation is v equals d over t. The only thing that changed in this problem was the frequency. The distance and the time stayed the same. So our velocity is going to stay the same. Nothing about that is changing. Okay? Now, our wavelength formula is wavelength is equal to our velocity divided by our frequency. Our frequency did change, so that means our wavelength will also change. So we're going to have 331.27 meters per second over 442 seconds to the -1, so the s goes up here. Cross that s out, cross that s out. You're left with meters. And so you should get a new wavelength of 0.76 meters. Okay, now, so we have that. Now the next thing they want to know is our period. And our period is in this formula. F equals 1 over t. Because our frequency changed, our period also changed. I'm going to go ahead, I'm going to put it in the triangle again. Okay, 1 and t. 1 is on the top, t is on the bottom, and f is by himself. And I want t. So I'm going to have t equals 1 over f. So it's going to be 1 over 442, remember seconds to the -1, which means that you'll actually have seconds for your unit, which is good because the units for period is time. And you have 1 divided by 442, so you're going to get 0.0023. You might also get, your calculator might give you this. And your calculator may also give you this. All 3 of these answers are correct. Make sure you have the units for everything. If you forget the units here, but you put the units here, I usually give you credit for it because I know that you know the units because you meant to write it here and you just forgot. So don't worry about that. Try these wavelength, frequency, period problems, and in class we'll work on them. And if you have any trouble, we'll talk about it.